Okay, just like exponential functions with different bases, remember we considered e to the x, and then we said, okay, well, what if it's 2 to the x? It's virtually the same thing. All you need to do was multiply by the natural log of the base. Well, we have the exact same thing here. The same thing being, what's the derivative of a logarithm where the base isn't e? And remember, natural log ln is a base of e. So what's the derivative of a logarithm when the base is not e? So what do? We do exactly like we did. You do for the log of anything. You do 1 over that, throw it into the bottom. You do the derivative of that. But then you also need to multiply by the natural log of the base. But what I want you to notice is the difference here is the natural log belongs in the denominator, in the bottom. Okay, so let's take a look at this. If we had the log base 4 of x, what would the derivative of it be? Well, the derivative of that would be 1 over whatever's on the inside, which is 1 over x, times the derivative of that. Well, the derivative of x is just 1, so we don't need to worry about that. But now we need to remember to multiply times 1 over the natural log of the base, which in this case is the natural log of 4. So what would the final answer look like? It'd be 1 over the natural log of 4 times x. Again, I don't care the order. You could have written x natural log of 4. I truly don't care the order of it. You could just swapped it because it's multiplication, it's commutative. Okay. Let's look at the next one here. It says g of x equals 3 times the log base 1/3 of x squared minus 3x plus 1. Good test problem here, testing multiple things. Do you know how to handle other bases, and do you know the chain rule? So a nice test problem here. So if we're finding the derivative g prime of x, we keep that constant multiple, the 3. Because it's a log, we're going to do 1 over what's ever on the inside. So this would be 1 over x squared minus 3x plus 1. We need to remember that's the first part. We need to multiply times the derivative of the inside. That's x squared minus 3x plus 1. We need the derivative of that. But then now we have that new part, which is 1 over the natural log of the base, which is the natural log of 1/3. So again, just like exponentials, we have 3 separate parts we need to deal with here. 1 over what's on the inside, the derivative of the inside, and then 1 over the natural log of the base. Well, now we need to clean that up. The derivative of x squared minus 3x plus 1 would be 2x minus 3. So let's put this all together. Looks like on top I have a 3. In parentheses I have a 2x minus 3. On bottom, I have the x squared minus 3x plus 1, and I also have that natural log of 1/3. Again, I don't care which order you put this in, but you do need all of those aspects in your derivative. You could have distributed out the 3, or multiplied the 3 out, so it could have been 6x minus 9. Absolutely no need. Don't waste your time there. Okay. Let's look at c here. This is log base 5 of the square root of 2t minus 1. I'm not going to lie, immediately the second my inside looks nasty, I try to use those logarithmic properties. You might not have caught that on this one, but heck, I would have, so I'm going to use it. So what I'm saying is this is the same thing as the log base 5. This is my original function, h of t. Is the same thing as log base 5 of 2t minus 1 raised to the 1/2 power, right? Square root is 1/2. And then I can bring that down in front. And that's going to save me from having to do a chain rule. So my original function is the same thing as 1/2 times log base 5 of 2t minus 1. Much, much easier function. So if I want to find the derivative of that, h prime of t, what would that be? Well, it would be 1/2. For any log function, it's 1 over what's on the inside, so 1 over 2t minus 1. We need the derivative of the inside, so 2t minus 1 prime, the derivative of that. Now we need 1 over the natural log of the base, so that would be 1 over the natural log of 5. What's the derivative of 2t minus 1? Well, that's simply 2. And then I notice that there's a 2 in the numerator and a 2 in the denominator, so those simplify. So put it all together, what am I left with? Looks like on top I have a 1. On bottom I have a 2t minus 1. I'm putting that in parentheses, the 2t minus 1. 1 sec, being stubborn. And then I also have that natural log of 5. So that's what I got. I have 1 over 2t minus 1 in parentheses. Make sure you have parentheses, and a natural log of 5. Let's look at the next one. Again, a great problem here because we're forcing a product rule. product rule, if you remember, if we want to find the derivative of this, is going to be 1d2 plus 2d1. First times the derivative of the second plus the second times the derivative of the first. Well, let's give that a go. What's the first function? The first function is x squared. Derivative of the second function, well, that's log base 2 of x. So that would be 1 over x times the derivative of x times 1 over the natural log of the base, so 1 over the natural log of 2. And remember, the derivative of x is just 1. So I have x squared times 1 over x times 1 over the natural log of 2. That's the first part. Plus, now let's do the second part. That's log base 2 of x times the derivative of the first. Derivative of x squared is simply 2x. Let's clean that up. The first part I have an x squared and a 1 over x, so that's going to simplify into x. So I end up with x over the natural log of 2 plus 2x times the log base 2 of x. There is technically some stuff that I could do there, getting common bases, doing a change of base formula. Man, I don't care about it. I could also factor out an x. I don't even care about that. I'm perfectly fine with this answer right here.